So, we have already done a few things in coordinate geometry. We have spoken a lot about line, right? Equation of line. How do we represent a line in the form of mathematical object or as a mathematical function? Lines are everywhere. You can imagine lines going here and there. You may not be able to see with your eyes, but lines are everywhere, right? Lines are everywhere. And that's why we need to know how we can define line mathematically. Do you see lines here and there? Lines are everywhere, you see. Everywhere. This is a line, that is a line, this is a line now, that is a line. Lines are everywhere. Huh? You may not be able to see it, but lines are everywhere. So, in order to talk about line, we need a reference. Where is the line? In which direction is the line going? Right? To know that, we need a reference. We need to say, okay, reference is always important. Reference is important in our life also. I have progressed in mathematics. How do we know that I have progressed? Or how do I know that I have progressed? Well, if I was getting 0 marks in the exam and I am now getting 20 marks, I have progressed. But if I was getting 80 marks and then now I am getting 70 marks, I have not progressed. So reference is important. Have you progressed or not depends on what you were previously, I mean a year back or 2 years back, right? So reference. So for reference, we take the origin, 0, 0, right? That's the origin of a Cartesian plane. We call it Cartesian plane. And this is where everything starts, right? So now we can draw lines everywhere, no matter where you want, isn't it? So let me draw a line here. Let me draw a line, let's say like this. This is a line. And this line is infinite, right? For the moment, I'm not going to restrict it. I'm not going to restrict this line. Let me just probably... Okay, should I delete it? Let me just get away with this one. And then draw a fresh one. Okay, this is a line, straight line. Huh? This is a straight line. Now, we should, just like how we give names to the people, in order to identify one from the other, we need to give a mathematical definition of this line. We need to give a mathematical definition. Somehow that definition should encapsulate, it should hold the uniqueness of the line. What did I say? Am I teaching English or mathematics? The line should hold the uniqueness of its identity, right? I'll give you another line. Is there some difference between these two lines? Obviously, the one is red, another one is yellow, dirty fellow. But the thing is, color is different. But we are not too small to actually talk about colors right now. This is just to make sure that it looks beautiful. But what is different?
Angle.
Their direction is different. Their direction is different. It is moving from this way to that way, or from that way to this way. And this one is moving this way. I can draw another line. And this one, let's say, this one. This is another line. but they are all different. So somehow we have to give them name. John, Ghanshyam, Prabhi. They are not human beings, right? So we need mathematics. What do we need?
Mathematics.
So that's where the equation of line comes. We need to know how, if I move x, how much y is moving. If I can say that, that is what line is. The identity of line comes from there. For example, identity of a person comes from मान्छेलाई कसरी चिन्ने? Identity of a person. Identity of a person. नाक ठुलो छ, मुख सानो छ, दाँत थोते छ, कालो छ, गोरो छ, चेप्टो छ, नेप्टो छ, गोलो छ, लाम्चो छ, ठुलो छ, सानो छ, खुम्रो छ, सिल्की छ. All these are the ways you use to characterize, to give an identity to a person. Similarly, line also has something of that sort. Not its color, right? Not the shape of the nose, because line does not have a nose, a mouth, all of that, but it has something special. Something special. What is that something special? Slope. If I increase x by a certain amount, how much y is increasing? That is important. That is how it characterizes itself. If I go from, let's say for yellow line, yellow dirty fellow, if I go from here to here, I'm increasing by this amount, right? Right? When I go towards x-axis from here to here, right? Isn't it? How much is y increasing? Y is here now, and then if I move here, y is here. So it's increasing by this amount. By this much. If I go from x from here to here, the line increases its y from here to here. Who can clear, sir? I'm trying to give you some explanation of what we've already done. Y x तिर यहाँबाट यहाँ गए भने y यहाँबाट यति गयो. कसको लागि? यो लाइनको लागि. के को लागि? यो लाइनको लागि. This is the fundamental identity of a line. X कति जाँदा y कति गएको छ. त्यसैले हामीले स्लोप भनेर भन्छ. स्लोपले धेरै चीज जनाउँछ. अब स्लोपले त x कति जाँदा, how much is y increasing when x is increased by a certain amount? So that it gives. We get that. But where exactly is it located? Here also, if you see, more or less it's happening the same with the green line also. But the other identity is, where is it located? You have to find one particular location. And for that we use the y-intercept. What do we use? Y-intercept. How much is y-intercept from here to here? Where is it cutting the y-axis? That's the y-intercept. This is the slope. So you need two things. Just like manchila jannalai for a person, you need first name and last name. Similarly, for a line, you need slope is the first name, last name is the y-intercept. Once you know these two things, you will precisely and exactly and accurately be able to know a line, where it is, how it is. Alright? So, with that, slope is m, we find the slope, we find y-intercept as c, and then we give the line y equals to mx plus c. This is the definition. This is the equation of the line. This is its identity, its blood, its soul, and its It's all and everything is y equals to
Mx
mx
plus
c. From y equals to mx plus c, you will be able to know each and everything about this line. Nothing is impossible. It's like a kundali, Janma kundali of this line. Similarly, a green line, let's write down. It can be, you can express it in a different way also. Another way of expressing line is x divided by a plus y divided by b equals to 1. This is another way of expressing
line.
This one can be changed to explain it this way. Here, m is the slope, c is the
y-intercept.
Here a is
the x-intercept and b is the y-intercept.
So either you know slope and y-intercept. You can write the equation of the line.
Or you know
The Janma kundali of that equation.
x,
Or you know a and b.
x-intercept and
X-intercept
y-intercept.
and y-intercept. You can write down the Janma kundali of that line. Or Raja. Or you can also if you know the perpendicular distance from the origin, and let's say the distance is p, and if you know the angle that this line makes, this perpendicular line makes with the x-axis, the angle is made between x-axis and the perpendicular. What is that perpendicular? The perpendicular distance from the origin to the line. Alright? So the line is here, that's why I have drawn perpendicular. If I have to draw perpendicular on the yellow line, I have to draw from here to here, right? Somewhere where it makes 90 degree with that line. So with that also we can express this line in this form. X cos
alpha plus y sin alpha is equals to b.
Alpha equals to b. And this is interesting, right? Because you have trigonometric functions that are coming into play. Trigonometry is always everywhere. So these are various different ways of
Expressing a straight line.
of a line. Right? Now, if you know the slope, you can immediately find the angle that it makes. If you know the slope, you know what the angle that the line makes with the x-axis. For example, if
slope is equals to 10 theta.
we know that, let's say, so this is the angle that this line makes, right? Isn't it?
Yes.
If we want to find the angle of this line, what do we do?
10 theta.